Hi everyone, welcome to IoT Show Deep Dive, where every other week we deep dive into a new topic, and today we are going to be focusing on confidential computing and IoT using the Open Enclave SDK. So you can see I actually have kind of a big panel with me today. I'm pretty excited. I brought in my friends who's been focusing on the Open Enclave SDK and confidential computing. Yeah. So I'm really excited to have all of you here. Let's do a round of intros. Eustace, did you want to start first?
Oh yes, my name is Eustace Asangawa. I'm program manager for focusing on security on Azure IoT. I'll pass it over to Hernan.
Thank you. Hello, I'm Hernan Gara, and I'm a software engineer in the same team as Eustace.
And I'm Dave Thaler. I'm a software architect, and I work in the operating systems IoT group with a focus on IoT security that we're going to be talking about today.
Yes, and I'm Pamela Cortez. I'm going to be your host, and so if you have any questions, make sure to ask them in the chat, and I'll pick up those questions and ask them for our fellow guest speakers today. I'm also on the Azure IoT team, focusing on IoT, so training developers and coding with them. So I'm excited to get started. All right,
Thank you, Pamela.
Yeah, definitely. So on the agenda today, we're going to do a couple of different things. One, we're going to spend the first about 5 to 10 minutes talking about what is confidential computing, what is this Open Enclave SDK, how's it all fitting together, and why is it important. Then we're going to jump into a couple different technical demos. And I'm pretty excited about that. We'll be showcasing how to get started and simplifying the trusted applications with Open Enclave. We'll be doing that in Visual Studio and also Visual Studio Code. So we do have some hardware too that we'll be playing around with later on today. All right, let's go ahead and get jump started in there. All right.
Awesome. So want to kick us off with some
Yes. All right. So I think a lot of us have seen this slide many times before, or at least heard of how many IoT devices are coming on to and being online and being connected. So we see that there's going to be 20 billion connected devices by 2020. And honestly, this slide is outdated every single day because I keep seeing this number grow and grow and grow to the point where it's just going to be trillions and trillions of devices connected. So we won't deep dive crazy into kind of this marketing slide, but really it's just to show that we have so many of these devices, and there's going to be a lot of devices that are edge devices, that's going to be maybe storing a bunch of data, that's going to be, especially with intelligent edge becoming more and more popular in IoT solutions, that we're going to end up seeing a lot of AI models at the edge. So if you have all of this IP, all of this data at the edge, how do you protect it? So we're seeing a huge growth in these IoT devices, and that's why I really thought it'd be great to get Eustace to come in and really talk about what is confidential computing. Eustace, did you want to kind of go through that and give an overview?
It's very good to introduce confidential computing, why this area is interesting and why it is important, and we cannot evolve our computing, especially at the edge, without it. So confidential computing is the ability to store, transport, and act on data and workloads without revealing the privacy or confidential information from that data. So the emphasis here is act, because traditionally in compute, we know very well how to encrypt information to transmit, encrypt information to store, but when it comes to acting on that information, which is what we call workloads, acting on that information, it becomes vulnerable at that point. So confidential computing seeks to close that gap on acting on information, and we are going to be talking in more details about the technologies as Pam mentioned, how we're going about that. So let's look at some of the motivations that is driving confidential computing in the industry and IoT as IoT is evolving. So the owners of IoT deployment, they have certain interests, and all of those interests, we condense it into 3 particular needs that require confidential computing to achieve security goals correctly. The first need is about a confidential treatment of code and data privacy. So in this particular case, it's a case where an owner of a deployment has some code, has some algorithms, has some data that they want to make sure that it doesn't get revealed while they're acting on it. It is good to talk about this through examples. So one of the examples may come from the medical field, where a medical device supplier would like to make sure that when they use, would like to protect their algorithms from being stolen. So what they'll have to do is, what they would really like to do is to collect patient information, bring it to the cloud, and compute it there so that their algorithms remain safe in the cloud. But when they do that, they run into the problem of privacy of patient data. So when they run into that problem of privacy, it becomes a problem there. So the solution to that is to move the algorithms to the edge. And when they do that, then they risk revealing those algorithms, which is really the secret sauce of their business. So for customers like this, they really need confidential computing where they can act on the data at the edge without actually revealing their source code. Then the second area of interest here is that with all this compute at the edge, the next thing to do is to be able to trigger actions directly from the insights that are coming from this compute. Pamela mentioned earlier about AI, machine learning, a lot of evolution in that space. So there are a lot of insights that are being generated from the compute information, and it just makes sense to trigger downstream actions from that compute. So one good example in this area is companies that are in the energy space, where they do energy generation and distribution. The challenge that they face today is that the traditional model of being able to estimate capacity is not working very well. Why? Because of many customers, they now harvest energy as well and contribute it into the grid. So it's really hard to estimate how much to generate. But if they can gather insights from a customer interaction with energy consumption and generation, they should be able to generate insights. Now, these insights are going to generate actions, which are going to control critical infrastructure. So it is very important to control that environment, that compute environment, to make sure that downstream critical infrastructure remains safe. And then finally, the third piece of it comes in the form of value transactions. So here we're talking like billing or tracking for warranty. This is one where a good example is a data scientist who has all these special models that they want to license and monetize on. If they're monetizing on these models at the edge, they don't have any way of really controlling and making sure that the models are being used and valued the same way. So with confidential computing, they get an in order to do this. So different applications in different verticals, we see the trend condensing to these kinds of needs where we would need confidential computing.
That definitely makes sense. And I can see potentially like GDPR maybe affecting the reason why, especially that privacy. So with more and more governments putting these regulations in effect, I could see pushing more on confidential computing and people getting started on it.
Oh, yes.
And knowing the need.
And it's good to get a great jump start on it before the regulations come in, because when the regulations come in, they come in fast.
Oh, yeah. Then they expect you to hurry up and put it in production.
Yes. Yes. So before we dive deep into this, we just want to mention the historical approaches to confidential computing. Obviously, it's going to evolve in the future, but up to now, there are two approaches to confidential computing. We just want to make sure that we have complete coverage here. We're focusing on just one. Mm-hmm. So one of the first approach is a technology called, a science or technology called homomorphic encryption. The idea here is that all the inputs, you can pre-encrypt all the inputs. So if you were to act on patient data, you can pre-encrypt the patient data at the source, and then when you go into the compute environment, you can compute on any machine. Because the data is encrypted, you're acting on it while it is encrypted, the information is not revealed. So it's a very good idea in concept, and it is still a very evolving technology. Right now, it is still new, Pamela, such that the things that you can do with homomorphic encryption is very limited today, especially when you go down the complexities of where compute is evolving at the edge today, like AI and machine learning. It is not available in this. So that is why the second option, which is what we are going to be focusing on today, is instead of going down the path of homomorphic encryption and relying on general compute hardware, what we need to do is to create what we call a trusted execution environment, sort of like a firewall area where you can safely do compute inside of it. So this is the technology we are going to be focusing on. We call this environment trusted execution environment, or enclaves, and the applications that run in this environment, we call them trusted apps. So a lot of times we use the word TAs for trusted applications, or TEEs for trusted execution environment. And some of the common hardware technologies that to create these isolations today are trust zone technology from ARM or SGX technologies from Intel. So we may be using the word trust zone and SGX, but that is the context in there.
Yeah, and are we seeing more and more, I mean, that covers a lot of hardware,
Yes.
but are we seeing a big growth of more support for Open Enclave?
Very great question. So we're seeing a lot of growth for the need for confidential computing. So traditionally, it is not new. The area is not new, but it has been niched in the past. So like in government or mobile industry or payment industry. So niche in the application space, niched in the supply chains, and now the need is needed in IoT. And the problem with IoT is that we have to expand this technology out. So when Dave comes back in, he's going to tell us why it is very difficult to move in this area and kind of justify why what we are doing is very needed right now in order to make it feasible for everybody. Yes, we're seeing a lot of growth in this area. So when we introduce the technologies that goes into it, the main part of it is what Pamela, what you said earlier, Open Enclave SDK and an API there. It's an open source project to help simplify confidential computing. So what you're seeing here on the slide is that we have the Open Enclave SDK as an open source SDK. It can layer on any trusted execution environment hardware, so rely on our silicon partners to provide this. And then in complement to that, we are building this not just to showcase the technology, but to be able to enable you doing IoT to be able to do it at scale. So we're going to provide cloud complement services to enable that deployment at scale.
That's great.
So in the long run, our goal really is to have access, is to give access to confidential computing to the data scientist or an independent software developer who may even know nothing about hardware, but have the concepts of being able to develop some intellectual property or some information that they need to protect and be able to detect and use confidential computing, at that level. So that is where we're headed, being able to do the groundwork that is needed for technology and make it accessible to all in the IoT space. Okay. So Open Enclave is an abstracted API. The same API, you're going to use it for Edge and also Cloud. We are making it in such a way that we only have one API surface to be used in Edge and Cloud. In the Cloud, we have products there like Azure Confidential Computing. So if you want to do confidential computing in the Cloud, that technology is there. But in the Edge, it's a little bit more challenging because you actually have to have the right devices in order to enable confidential computing at the Edge.
Yeah.
Okay. So for this, we are working with many partners, many OEMs, in order to create these devices. What we see here, Pamela, is one of the partners that we work with. It's a company, Scalise. We work in collaboration with ARM, NXP, and Arrow. And the goal here is to showcase how a supply chain of of devices for confidential computing can work together. So in this particular one, the first device that we worked with Scalise, it won an award for the best of innovation in the CES 2019 for cyber security and privacy. So we are very proud of that. That is validation that the work that we are doing, it is being accepted. So this is an industrial grade device. For anyone who is developing, you can use this as your pre-pilot devices. It is already industrial grade. It is using tamper-resistant silicon from NXP. LS1012 is the particular silicon in this device, and the LS1012 is one of a family of many devices with different compute capabilities. So anybody using TrustBox Edge have an ability to be able to work with Scalise and get the compute level that they need.
And for folks who are looking for devices, will we have anything in our device catalog for our Edge devices that are compatible with the Open Enclave SDK, or?
TrustBox Edge is going to be going on. It is available at Arrow right now, and it has IoT Edge pre-installed right now, and at some point it's going to say IoT Edge certified, because they're going through the certification process now, and once they get it certified, it's going to appear on Azure Device Catalog.
Okay, perfect.
Yes.
Yeah. Well, we always get that question of what hardware
Correct.
to use
Yes.
and what actually supports IoT Edge. So it's great to see.
And there's a link there to arrow.com. If you go there and search for Trustbox Edge, then you can pick up that device and procure it there. So it is available today. And
Okay, great.
the hands-on that we are going to do today, you can try it on Trustbox Edge. Okay.
Great.
Thank you.
Well, thank you, Eustace, for giving that overview of convention yes, tongue-tied, and Open Enclave. Yep, SDK. Perfect. All right. Well, it looks like Dave, can you give us more of a deep dive, and then we'll jump into one of the demos?
Sounds great. So let's go ahead and talk about what happens before you use the Open Enclave SDK, right? What is classic applications, and so what are the security issues that people run into today, right? And so here's an example where people are protecting, say, data at rest, right? They say, you know, I've stored all of my keys in something like a TPM, and I've encrypted all of my data on disk, for example, so all of my data at rest is protected, right? And then I use something like a TLS protocol across the wire, and so all of my data is protected in flight, and therefore I'm good, right? Well, it turns out that based on all the malware attacks that we're seeing, they still get compromised, especially in the critical infrastructure sector, right? You've seen all the articles about energy grid attacks and so on, right? And so why is that, right? Well, it's because there's a third leg of the stool, if you will, that's not being protected, and we call that data in execution. And so what happens is that while the application is running, right, or the malware comes in, and it either replaces the code or modifies the code or modifies the memory that code is using. Okay? And so what happens is that anything that's inside that little red box there that deals with the decrypted data or the not yet encrypted data, right, gets modified. And so, for example, the malware will take and generate, say, a command, use the command example. It'll generate the wrong command, and it'll say, hey, TPM, can you sign this with the correct key? And of course, then it goes out encrypted across the TLS channel, signed by the correct key, but it's the wrong command. Okay, this is where a lot of the malware attacks are happening today. Okay, and so it's that part that's in the red box that's the part that is the at-risk part for data at execution. And so instead, if you take that part in the red box, okay, and we move that over and we run that in what Eustace referred to as a trusted execution environment. Okay. The trusted execution environment, you can see here now the application's been split into two parts, right? There's the normal part on the left, and then there's the secure part on the right that's inside the trusted execution environment, okay? And so the trusted execution environment is what provides the protection against the threats that we're talking about. So what is a trusted execution environment, right? So what's the technical definition, right? Now there's various definitions that are out there, but the definition we're going to use in this talk, okay, is anything that meets the following two criteria. Okay. Number one, it has to protect that any of the code that's running inside that red box is only the authorized code. Okay. So what that means, for example, if there's malware with like a buffer overrun that tries to inject code, that code will simply not execute for one reason or another. Okay. The second property that it has to meet is that any of the memory that code is using is protected from access by code that's outside. So that means the malware can't mess with the memory either. Yeah. Okay. Because remember I said that the malware will either replace the code or modify the memory. And so those two constraints are what's necessary to protect against those data and execution attacks. Okay. Yeah. And it's the hardware enforcement, right? Since the malware obviously cannot change the hardware, right? It can change any of the software potentially, but it's the hardware it can't change. Okay. Yeah. So once it's hardware enforced, that's what provides a fairly strong cryptographic protection. Okay. Now, there's a number of different vendors out there. As Eustace mentioned, there's Intel SGX, there's ARM Trust Zone, there's Secure Elements. All these are things that are already widely deployed that meet those two constraints.
Yeah, what about Azure Databox Edge?
There's other things that are from Microsoft, for example. Yeah. And so Databox Edge.
It's a candidate, but right now we started with Azure IoT Edge, and we're going to roll it out to the different intelligent edge products.
Thank you.
Yes.
Okay.
That was Eustace, yes.
Yes, and I don't think people could hear him on the speaker. Okay,
go ahead.
But can you say that again one more time, Eustace?
Yes.
Yeah. He's jumping in.
No, I was saying that Databox Edge is a candidate. We're starting with Azure IoT Edge, and then we're going to roll it out to the different intelligent edge products within Microsoft.
Okay, perfect. Thanks, Eustace.
You're welcome. Across the camera.
Okay. So let's go ahead. Now, I mentioned that there's processors that are widely deployed, right?
Yep.
And so, for example, the laptop that I'm using in front of me, this is just this one is a Lenovo ThinkPad, right? This one is fully SGX capable, right? There's devices like the TrustBox Edge that Yusuf just showed that is just running an ARM processor that's fully trust zone capable, okay? But today, if you look at, say, applications and app stores, and for example, there's thousands and thousands of applications out there, right? But how many of them actually use these chips, right? Because they're running on chips that have these capabilities on it, but they're not using it, right?
Yeah.
So all this hardware protection that we have against malware is just not being used today, okay? So why is that, okay? Well, it turns out that historically there's been two main reasons why it's been really hard and why we haven't seen it taking off yet, okay? And that's what we're going to be talking about today. The first reason is that the APIs that were usable from when running inside of a trusted execution environment, right, whether you're running inside SGX or Trust Zone or something else, the APIs that you have to use from the code is not the APIs you're used to, right? I'm used to regular POSIX APIs or whatever it is, right? And they're just not available because the APIs are different, okay? The second problem, and so of course that makes it difficult for developers, right, to learn how to do that, right?
It's more upscaling.
Exactly, yeah. And so the second problem is that the tooling that they're used to using, such as Visual Studio and Visual Studio Code, the tooling is just not integrated there.
No.
Okay, and so it's actually been fairly hard. And so that's why it's two big blockers. I don't even know how to get started, right? So that's what we're actually going to be addressing today, right? If you're interested in addressing those two problems, you've come to the right place.
Yeah, and there's so much research that's being shown of why there's so many hacked devices. It's because lots of times developing secure platforms, it's hard.
That's right.
And to the point where they're just pushing out the actual devices
Yeah.
And hoping that no one hacks them. But
That's
yes,
right.
yes.
So today, the first problem about the APIs is what the Open Enclave SDK addresses. And the second problem about integrated environments is what our Visual Studio and Visual Studio Code extensions address. And we're going to walk through both of those today. Now, let me start with the Open Enclave SDK before I get into the demo part. The Open Enclave SDK has a number of goals, okay? For the developer scenarios, the first goal is I've already got some application, like the first one in the red box there, and I want to split it into those two pieces and move part of it, right? And so I've already got some code, and I want to lift and shift that code as much as possible over into the trusted execution environment. How do I do that, right?
Yeah,
it's already calling the APIs that I'm used to calling, right?
Yeah.
So that's one of the scenarios we want to make it be really easy. The next scenario is I want to make it be really easy to start off with something that's new, right? I don't have existing code to move, but I want it to be as easy as possible to author brand new code.
Yeah.
Again, using the APIs I'm familiar with, okay? We also want to allow people to create libraries that are independent of whether it's running on SGX or Trust Zone, right? That gives a greater ecosystem of libraries, SSL libraries and things like that, that says, okay, I don't need the SGX version of the library to be different from the Trust Zone version of the library, right?
Yeah, you just want one code base.
So that way developers can say, I'm going to pull this library, I'm going to pull that library, and they don't have to worry about, well, that one was developed for Trust Zone, well, I can't use that, or that one was developed for SGX, but I'm Trust Zone, I can't use that, right? So we're trying to solve this problem, give a greater ecosystem of libraries for people to be able to reuse. Finally, we want it to be able to be the same SDK to support both Windows and Linux. Okay.
Yeah.
Now, today, since we're IoT focused, all of our demos here, we're actually going to be showing you the Linux walkthroughs. I want to develop code for Linux, even if I'm using a Windows development machine. Okay. Now, some of these tools, they also work fine with Windows as the host, but the demos that we're going to walk through today are going to be building to run on Linux machines. Okay. And then finally, we want it to all be open source. Everything that runs inside of a trusted execution environment and so on, it's all open source, Open Enclave SDK, 100% open source.
And who's maintaining the main Open Enclave SDK?
Well, there's a new organization that's called the Open Enclave Organization. And when I say organization, I mean it in the GitHub sense. And so the initial maintainers are Microsoft, but that's not the intent over time, that additional contributors are welcome. So, all right. So if we go back to that picture and we kind of blow it up in terms of the code that moves inside the trusted execution environment, this is showing how the Open Enclave SDK fits in. And so in the very top left and top right, you see application normal part and application secure part. And you can see each of those sit on top of an open enclave. That's the OE host API and enclave API, right? If we rename the left side and the right side, you can see we're using the term host to apply to that application normal part and the term enclave to apply to that application secure part, right? So if you see us using those terms, that's what we're talking about here. So there's a host side of the API and an enclave side of the API. So for example, the enclave side of the API, this is what presents the standard APIs you're used to, right? Like the POSIX APIs, for example, right? That's serviced by the Open Enclave API, Enclave API. Okay. Now, in between, the host and enclave have to be able to communicate with each other, right? But there's a processor context switch that's in between those that can be difficult to deal with if you're trying to write code, because that varies by whether it's SGX or trust zone or whatever else. And so this is done for you again. So the developer authors what we call an EDL file, or an enclave description language file. It's very similar to the RPC programming model, right? In RPC, if you've done RPC programming, right, you typically author an IDL file, and then the code generates some stubs based on the IDL file. That's what's going on here. The EDL file generates code that you can look at the code, right? That's on both sides, that takes care of making the calls work. So the host calling into the enclave, it just looks like a normal function call because the generated code takes care of that for you.
That's good.
Okay, so that's what you'll see. And you can see on the right, it sits on top of either SGX or trust zone or potentially other things in the future, right? The goal of the Open Enclave SDK is also to make it easy for somebody to plug in some other ecosystem on it, like secure elements, for example. Okay. And then on the left, you can see it can go over either Linux or Windows. Okay. So that's the application architecture. And when you see the EDL file, you see how that fits in as generating the way to communicate between host and enclave. The last piece of terminology that I'm going to show is the way that the calls work if I were to blow up that horizontal line on the previous slide, right? The call from the host into an enclave, okay, or an enclave call. If you see the term eCall, that's what that refers to. It's a call into the enclave, okay? And so the way that the enclave calls work is the enclaves are always passive. They're just a library, right? The host calls into them, the enclave does some work, and it returns, okay? So that's what you see the eCall processing, and at the bottom the return from the eCall. Now, there can also be calls where the enclave code can call out to the host piece of the code, right? The normal part of the application, right? And we call that an outcall or OCall, okay? And so an OCall can happen in the context of an eCall, and we'll see that in the demo here, okay? And so this means that the way that you split an application between a host side and an enclave side is just at a function call boundary.
Okay.
Make sense?
Yeah.
Okay, so that's what we're going to see. So now we're going to bring up, I'm going to do Visual Studio first, and then afterwards, Hernan is going to come in and do the Visual Studio code. And so I'm going to flip over to Visual Studio here. I'm using Visual Studio 2019 here, right, the newer version. This also works fine with 2017.
Okay, so you can go as low as 17.
Right, 2017 or 2019. There's an extension here that I've already pre-installed. This is in the Visual Studio Marketplace. You can install it the same way as you install any Visual Studio extensions. You can see it's called Open Enclave Wizard Preview, right? So for example, if I were to just search for the word enclave, right, and look online, then you'd be able to see that in the online section to be able to install it, okay? And so this is what I've already installed inside here.
Okay.
And so this is what we're going to use. But I'm going to do the workflow that says I've already got an application, okay? But just to make it be easy, I'm going to create a brand new application, then I'm going to do that to you. So let's use File, New Project. And since I mentioned we're going to do the Linux workflow from inside Visual Studio, right? For those of you that haven't seen this before, yes, you can do Linux development from inside Visual Studio.
I was waiting for that.
Sorry, that's not part of Open Enclave SDK, right? Visual Studio added that recently. Did you know that?
Yeah.
So I'm going to look for, I've already installed the Linux extension as well, right? And you can again find this on the marketplace, and there's walkthroughs online and so on, okay? And so I want to choose the console application for my demo. I just want a simple hello world application. And for clarity here, I'm using console application here, not console app.NET Core in this demo, right? So don't be confused if you're trying to try this on your own, okay? And so I'm just going to leave the default settings here. This is just going to create me a hello world application that's not going to have anything to do with Open Enclave yet. And then I'm going to add Enclave support into this application. Okay. And so you can see when you start off, the Linux extension gives you this little walkthrough of how to configure it and so on. And so what happens here is that in order to build and test for Linux, you need a Linux machine, right? And so 3 examples of ways to do that. You could have a separate physical Linux machine sitting next to us, like if I was going to use, the Trust Box or just a regular Linux laptop or something like that. Or I can use an Azure Confidential Computing virtual machine. And so if I sign up for Azure Confidential Computing, I can get a VM in the cloud that does this, right? That's the second example. Third way of doing it is I could just run a Linux VM on the same machine. And that's what I've done here. I've actually got a Linux VM that's already set up on this machine. And that's what I'm going to use for debugging and compiling and so on.
Okay.
And so in Visual Studio, and this is what the Linux walkthrough that's on the screen back there tells you to do, is inside Options down here under Cross-Platform, there's a connection manager, and this is where you can configure the IP address or host name of your virtual machine or your physical machine. And you can see I've already done that, and it happens to be pointing to you. And in this case, it's an Ubuntu. It supports either 1604 or 1804 Ubuntu right now. Okay. And so here I've got an Ubuntu 1804 VM running on the same machine, and here's the IP address it's configured in here. Okay. Now, if you have multiple of those configured, then, yeah, go ahead.
Oh, go ahead.
If you have multiple VMs configured, or let's say your IP address changes or whatever, so you add a second one, then it's important to know that the Visual Studio extension is new enough that you have to make sure that's working. And so here inside the properties of this project, you can see right here, remote build machine, okay? And if you have multiple of them, then this is not bolded, but I have to force it to be bold because sometimes if you have multiple of them, it doesn't pick the right one yet, okay? So if you're gonna try this tomorrow until like an update or whatever happens, then just make sure you turn it to be bold and then apply, okay?
And what happens when you don't bold it?
It will fail to connect.
It will just fail?
It'll give a trying to connect, and I'll show you where the connection part happens, and you'll see it'll fail right with failure to connect.
Okay, perfect.
If you are using 2019 Visual Studio instead of 2017, under debugging, you can choose the remote debug machine. Okay, 2017 it automatically is the same one, but on 2019 it could be different, and so we got to do the same thing here. We'll just force this to be bold. Now, since I only have one in that list, and I deleted all the other ones, then of course this would have actually worked either way. But once you add a second one, that's when, just a fair warning, make sure you don't run into this problem. Okay. So at this point, I should be able to build and execute. So I'm just going to set a breakpoint, say on this printf here, just so you can see the before picture. Okay. So I'm going to hit F5 here, and if I look down here at what it's doing in the build window here, okay. Oh, that's interesting. I'll just go on to the next part here while that's trying to build. Let's make sure it's trying to build. Okay, there it goes. Could not connect here. That's the message you should get.
Yes.
Okay. So let's make sure that that is the right IP address. So I'm just going to connect to my VM and verify that that is the right address. And so you can see this is just a regular VM, and so you can see my IP address here is the one that ends in 26.163. And so if we look back here, and we just make sure 26.163, that is the right one. So let's just make sure that I set it correctly here. 26.163. All right. Let's go ahead and compile. Again, I'm not using Open Enclave SDK yet. All right, well, I will continue to go on then. All right, I'll go to the next step anyway, because the next step is the use of the Open Enclave SDK. So at this point, we want to create, connect to the remote system. Next targets. Okay. Yeah, this is the message you'll get. Now I've demoed that for you.
There you go.
All right, there you go.
So you'll know what message you'll get if you haven't been fully connected.
So I'm going to add an existing project into the same solution. Okay. And so at this point, now I'm going to actually use the extension that we've installed here. So if we look for, say, Enclave, you can see there's Windows projects and there's Linux projects. Okay. Now, since I'm developing for Linux, I'm going to choose the Linux project. Okay. And I'm just going to leave the defaults here. You can set it to be whatever name that you want. Okay. And this is actually going to be creating some empty code that's like a hello world type of thing for an Enclave project. Okay. Now, of course, the two left sides, the left side and the right side of that diagram that we showed, are going to be two separate binaries, right? This is actually going to be compiling a separate binary that gets signed to run inside the trust execution environment. Okay. And so for this one, we're going to need to use, since this is a new binary, we're going to need to use that same step here and change the remote build machine, to make sure that it's the correct build machine. And if we look at the code that's generated here, right, you can see it's generated a couple of files in this project. Here's an EDL file. We talked about that. So here you can see, here's an example of a call that's exposing for the normal side to be able to call. Here it's called ecall do work on Enclave. You can name it whatever you want. For the calls in the opposite direction that can call back out, you can see here's a do work in host. Again, you could add multiple things here. You can rename them, whatever you want. Okay. And so this is what we'll use to generate the code. Now, of course, we have to have implementations of both of them. And so if the e-calls are, of course, implemented in the Enclave, right, because there are calls in there. So that's this e-calls file that was generated for us. And so here's just a simple implementation of the e-call, right? You can see this one does a printf, and then it calls do work in host, right? So here what you'll notice is the fact that this is including standard I/O and it's calling printfs,
Okay.
This emphasizes the point that I can reuse the same APIs that I'm used to using, okay? And the fact that I can make calls back out on the other half of my application also works fine, okay?
Okay,
so
nice.
here I could do things like I could set a breakpoint inside here, and if we debug inside it, we'd see this on the stack, okay? Now, of course, all we have right now is we have a library in an application that never calls the library, right?
Yeah,
So we're kind of missing a step,
yeah.
right? So we still haven't written any lines of code, right? I'm just showing you what's been generated, okay? And so we'll see if that one builds. That one will probably give us the same error because something's wrong on my Visual Studio instance here. But let's go back into the console application here. So how do we take this application and say, I want to call this enclave? Maybe I've moved some of the code in there. Maybe I've written new code. How do I do that? Okay. So if I right-click, same way I go to Properties, okay? And so here you can see it's getting generated the same error for me. In the console application, let's make sure we set that one as our startup project too. Right. Let's say right here above Properties, we see Open Enclave Configuration. Okay, this is what the extension provides this. If you don't see this, it means you don't have the extension installed. So if we choose this one, you can see right here, Import Enclave. So I'm going to choose that one from my regular application, and it's going to say, what is the EDL file I'd like to reference? And so my EDL file was down here in my Enclave 1 project, and here's the EDL file. So I picked the EDL file. It says, this is what I want to be able to call that interface. And so at this point, this is going to work for a bit. And so this is going to be making some project settings changes to make sure that it can compile and it can reference that. You can see it's added in references to these proxy stubs that will get generated. It's taken that same EDL file and it's added a reference to it from inside here. This is not a different EDL file. It's adding a reference to the same one. Okay.
Okay, it's just updating it.
Exactly. And so finally, it's added this other file here that's called _host. Right. This is sample code that you can modify at will. All right. So up here under generated files, these are the ones that will automatically get replaced whenever you change the EDL file. Down here is sample code. So let's look inside the sample code here that is added to my project. Okay. So at the very bottom here, you can see here's an example of the implementation of the OCall. Because remember, OCalls are implemented, the implementations are in my normal part of the application. Okay. So you can see here there's just a printf, and I could even set a breakpoint inside there. If I scroll up a bit, you can see there's code here that calls Open Enclave SDK APIs, like here is OE_, right? This is what will load the library, right? It says, I'm going to have a dependency on this my Enclave 1, and I'd like to create a reference to it so that I can call into it, okay? And so here's an example wrapper sample enclave call. You can see it does the create, and then it makes a number of eCalls, in this case just one. You could have any number of them. Inside loops, doesn't matter. You could split these into different functions. The point is you can make eCalls that just pass in the enclave pointer as the first argument. Okay, this is the enclave pointer you got back from the create. And then once you're done, say when your application exits or something, then you can terminate and exit. This is similar to like a load library or something that would dynamically load any dynamic library. Works the same kind of model. Okay. And so now that we have this sample code that would actually work, right? The problem is now that our main still doesn't call it, right? All we're going to do is printf, right?
Yep.
So let's add a call. Now here you'll notice that the default project generated a C++ file, but our host file is a C file. Right?
Yeah.
And so in order to call between them, of course, we just need our standard C construct, extern C. And so I'm going to add the prototype for sample enclave call, and then I'm just going to call that. Okay. So that's it. And so at this point, if the connection was working, then this would be able to compile, and I would be able to debug. And so if this doesn't work right now because my VM isn't accepting connections or something, I'm not going to take time to restart the VM right now. And so if I hit go, then I would be able to see the full stack on call stack here. And I would be able to set breakpoints both inside and outside. I can do source level debugging with just next, and I can see the printfs inside the window in here. I don't even have to look in my VM because the console is actually mirrored into a Visual Studio window by the Linux extension.
It's super useful.
Okay, there you go. All right, any other questions?
No, I'm not seeing any more questions on chat, but if you have questions on chat, make sure to don't be shy. Go ahead and ask them, and then
So let me summarize what I just showed you, right? Because then we're going to hand off to Hernan for the Visual Studio Code demo. Okay. So again, what we've done here is we've taken a regular Linux application, we've compiled it and run it on from Visual Studio on Windows, but being remotely executed and compiled into a Linux VM
Yep.
or a Linux physical machine, whatever. Okay, we've been able to do source level debugging and be able to see the full call stack and variables and everything else right here integrated in Visual Studio, the same way as you're used to. And we've done this by having an enclave here. And we've done that using the import, so we can take any enclave and import it into any console application. In fact, we could take multiple enclaves and import them and be able to use multiple at the same time.
Nice, nice. Wonderful. Well, thank you so much, Dave, for showing us this demo. I'm really excited to see the next demo in Visual Studio Code.
Okay, let's go ahead and do a similar demo with Visual Studio Code, and so I'm going to hand off to Hernan.
We did have a question about what are the steps for using for the Windows application? Because we did this for Linux. Is it the same logic, or is it pretty much the same steps?
Yes, in fact it is. There's online, if you go to the Visual Studio extension, okay, and you find so you can find this in the Visual Studio Marketplace. There's a link for more info from the Visual Studio extension, and there will be walkthroughs for both Windows and Linux. Here we've just shown the Linux workflow, but the Windows workflow is very similar. Windows, of course, you don't need a virtual machine, right, because you're already on Windows.
Yeah.
So the same workflow does work for Windows. It's just you don't have the headache of having to have a separate virtual machine or even a separate physical machine. It just works on the regular Windows. But otherwise, the workflow is the same. You create a regular Hello World application. You can create, you saw when I created the Linux Enclave application,
Yep.
you saw there was a separate project for creating the Windows version of it, and that just sets the Windows compiler settings, right? Because the code is the same either way, right? Whether it's Windows or Linux, but the Visual Studio settings to compile it is different, and that's the only difference between the projects, right?
Okay, well,
but
that's
otherwise,
nice.
import project works the same. Everything else in the workflow would be the same.
Which is actually the reason why it's so powerful, is because it can go from Windows to Linux using the same code.
Correct.
Yeah.
The code is exactly the same in
Yeah.
both cases. Again, the only difference is the Visual Studio project settings for whether you point to, say, a remote machine to do the compilation, whether you do it locally, and
Yeah.
which compiler that it's invoking, things like that is the only difference.
Perfect. All right, let's go to the next demo.
Okay, hello. So I'd like to show you two things. The first one is how to write, build, debug, and debug enclaves for ARM Trust Zone using the Enclave SDK and Visual Studio Code. The second thing is how to write, build, package, and deploy enclaves for ARM Trust Zone using IoT Edge, the Enclave SDK, and VS Code. So let's get started with the first part. So I have here Visual Studio Code open. And as Dave mentioned, we are targeting Linux to run our binaries, but we're indeed working on Windows here. So I'd like to show you first what the setup is like. So I have here Hyper-V, and I have, just like Dave did, an Ubuntu 18.04 server VM running. And in Visual Studio Code, I have an extension installed called Remote Development. It should be somewhere down here so that I can show you. Remote Development. It is currently in preview, although it is publicly available. And what this does is it allows Visual Studio Code to connect to a remote machine, and everything that you do in Visual Studio Code, even though it is running on Windows, all of the actions that you take will in fact take place on Linux or whatever other remote machine you have connected.
Okay.
You could, of course, use Visual Studio Code and do all of what I'm doing directly on a Linux machine if that is what you want. So I have another extension installed in the remote machine, so through Visual Studio Code, called Microsoft Open Enclave. So this is the Visual Studio Code port of the extension that Dave showed us in Visual Studio. And it provides us with a new Open Enclave solution command. So let's bring the Visual Studio Code command palette with F1, and we'll do a new Open Enclave solution. And the extension asks us for a location where we want to put the solution in. And this is indeed a listing of the files in the home directory inside the VM that we're going to be using as a developer environment.
Okay.
So I'll go into Devel, VSC, and click OK. And the extension also asks us to pick a solution type, so either standalone or edge container. So the standalone solution type corresponds to the first thing that I want to show you, where you develop binaries for the host and the enclave that can be run independently on, say, a trust box or some other ARM trust zone capable device. And the second solution type is the edge container, which allows you to take an enclave and a host and package them in an IoT edge module and then deploy them at scale to other devices that you might have. So say that you have a fleet of trust boxes, you can use this to deploy a trusted application on the host at scale. So we'll do the first one.
Yeah, and is there, if you started off with standalone and just wanted to go with edge container and actually run it with the IoT edge runtime, is there some sort of way to do that easily, or will you just need to start off with knowing that you need the edge container?
Good question. And this is something that we're currently working on.
Okay.
So in the future, we hope that we will have a single solution type and you can switch between the two.
Okay.
But currently, that's not the case.
Okay.
So we'll do standalone, and we have to pick a solution name. So we'll say standalone 1. Oops, let me spell that. Standalone. Let's do enter. And now the extension will do something similar to what Dave showed us before in Visual Studio, where it will expand a template that has an EDL file, a host, and an enclave. And there it finished. So here we see an EDL file, which is named after the solution name, standalone1.edl. And not too dissimilarly to what Dave showed us before, we have one eCall here in the trusted block,
Okay.
where the eCall is called eCall handle message. It takes in a string. The eCall will then do something with that string inside the enclave and return the result of that string manipulation that it'll do in the enclave_ms parameter. And so the host will then be able to read that and, well, it'll do things with it. We'll see in a minute. Now, in the untrusted block, this is where ocalls are defined, and we have one ocall called ocall log, and this one just takes a message parameter, a string, and it'll then print it out to the console.
Okay.
There is technically no need to do this, in the sense that you can just do printf from inside the enclave because we have POSIX APIs exposed.
Yeah.
But we have this one just to show that it works.
Okay.
That's pretty much what it is. Okay. Now, on the left-hand side in the Explorer, we have the enc folder and the host folder. So the enc folder corresponds to where the enclave is implemented and where the ecalls are implemented. And then on the host, in the host folder, we have indeed where the host component is implemented and where the ocalls are implemented. So let's have a look at the main.c file. And the main.c file is relatively simple. It calls into the openEnclave function, which creates the enclave. Call enclave performs an eCall into the enclave from the host, and close enclave terminates the enclave, so it unloads it. These three functions are implemented in host.c, and we have here the openEnclave call, which then in turn calls into the OE_create standalone one enclave. This is an auto-generated function that's generated by a tool that processes the EDL file, and it is the same, the same signature as the API that was used in Visual Studio to target SGX. So
Okay.
you can use the same openEnclave APIs to target both T's, and it looks just the same. Here's the call enclave function, and it performs an eCall, so it calls into the RPC stub on the host side that will then translate the call into the eCall, in this case in ARM Trust Zone. And down here we have the close enclave function, which calls OE terminated enclave, which unloads the function, and this is indeed also an openEnclave API. Lastly, up top is the ocall log implementation. So when the enclave calls back into the host via an ocall, here's where the implementation lives. Let's have a look at the enc folder, and it's only one file, enc.c, and here is where the enclave's eCall is implemented. There's indeed only one, and it takes an input message, it does some message processing on it, and it puts the result inside a little JSON block. So you might notice that there's the word signature in here, and this tells us what one of the things that you could do with an enclave. So for instance, say that you had a key that you wanted to protect, but you wanted to sign messages that come into the enclave. So the key never leaves the enclave. You can protect it in the T, and then you can use it to sign messages, say. It's one usage scenario. Of course, you wouldn't want to sign just any message, otherwise you just have a generic signer, and in that case, protecting the key doesn't do you much good. So you might want to implement some policies to make sure that you don't sign just any message.
Okay.
Sounds good?
Yep, makes sense.
Okay. And then the last thing the Enclave will do is it'll call the OCall back into the host and pass the message out, just to print it out to the console. So what can we do with this? It turns out that if you take an ARM trust zone enclave and you deploy it to a trust box or some other ARM trust zone capable device, and you run the enclave, you can't debug it. So you might be able to wire up a hardware debugger, say a JTAG debugger, but those are expensive and sometimes they're kind of hard to use, and there's a bit of a ramp-up time, and it's really not as nice as using Visual Studio Code.
Oh.
So what do we?
Yeah, I might be biased because I'm a hardware engineer, so,
Oh.
so I'm like, yeah, no, it's fine. But yeah, if you're the data side, you're not going to want to do debugging with a JTAG. You actually just want to be able to do it in VS Code. Yeah, you didn't hurt my feelings.
I didn't know. Okay, moving right along. So the extension also provides us with a list of. No, that's all I wanted to say about that. So let's continue, and it'll make sense in a minute.
Okay, perfect.
Okay, so the extension provides us with a list of tasks that we can run to build for 3 different targets. So build for QEMU ARM v8,
Okay.
build for QEMU ARM v7, and build for TrustBox Edge LS1012A. So the first 2 are builds that target an emulated environment. So the v8 one is a 64-bit target, and the v7 one is a 32-bit target. And the TrustBox Edge is a real hardware device.
Okay, so anything with a Q email is the simulated device.
Exactly.
Okay,
So
perfect.
QEMU is a hardware emulator, and it is capable of emulating our trust zone as though it were running on a real device.
Yeah.
So we'll do that, and the task will automatically kick off a CMake configuration step. This is indeed a CMake-based project, and it'll build the host on the enclave. And hopefully this will only take a second, since I did this before, and most of the output should be cached.
Okay.
And there we are, we're finished. And the outputs went into the build folder. So if we open this up and we go into the QEMU ARM v8 folder, we'll see under out, bin, is where our outputs are. So standalone 1 is the name of the executable, the host. And in ARM Trust Zone, the enclaves are identified by UUIDs. So we have to find which UUID our extension generated automatically for us. And it's the one that starts with 8AB. So if we have a look at 8AB, here it is, here's the enclave for Trust Zone. So how do we debug this? Let's go into the debug pane, and we'll notice that there are 2 launch configurations, ARM v7 and ARM v8. So we just built from v8, so let's pick this. And let's put a few breakpoints before we start.
Okay.
So let's go into the Explorer, host, main.c. Let's put a breakpoint in the main function, and let's put a breakpoint inside the enclave. So here is the eCall, put a breakpoint here. And now that we've done that, let's launch the launch configuration. You might see this error. We can ignore it safely, and the reason is because Visual Studio Code sees some missing headers. We'll fix this shortly, but for the moment it sees these errors and it figures, oh, your build failed, but it's not really true. If we go into the terminal, that was really fast. This is QEMU booting, and we can see here the boot sequence of Linux booting inside the emulator. So let's log in as root. There is no password, and let's do uname-a. And we will see here that this is indeed Linux running on an AArch64 emulated machine, or ARM64. Now, so how do we run the host on the enclave from inside the emulator? So the emulator has visibility into the development environment. So it has mounted the build folder inside the emulator. So we can go into here and do, say, ls-l mount host bin, and this listing matches what's in this folder.
Okay.
In enc out bin. Things are not being copied around, so it's the same folder being mounted inside the emulator. So whenever something on the outside changes, it also changes inside. So the launch configuration would normally launch the host, such as in the same way that the Visual Studio extension did for Dave's demo. But here, what the launch configuration launches is the emulator, and it connects the debugger to it. So we
Okay,
have
that
to-
makes sense. That makes sense.
So we have to manually launch the host for the moment. So we'll do mount host bin, and then the name of the emulator of the host, which is standalone 1. We'll do that. Hit enter. And now our debugger has stopped in the main function of the host. And we can debug this in the usual fashion. So F11 we can step over. Here's the call into the enclave create function. So we'll do F10 and step over that. And the result is hopefully A-OK. It is. So we'll release the emulator, and now we are inside the enclave. So this is the eCall running inside the emulator trust zone enclave. And we can even look at the local variables. We can look at the call stack as well. The call stack has a few other things on top of it, and you don't have to worry about what that is. It's their trust zone architectural calls, and the Open Enclave SDK handles that on your behalf.
And then the documentation for understanding what those actually are, that's online. Is it fully documented on what's happening in the back end?
In terms of how the Open Enclave SDK deals with that,
Yes.
partially.
Okay.
The idea too is that as a developer, you don't have to worry about what the Open Enclave SDK is doing, unless you really want to know. So you can just write your eCall, implement it, debug it, and then deploy it into a real device.
It works.
How we get there just works. Exactly. So we can step into this, over the sprintf call, and then into, say, the O call. And since we're already in the debugger, we can go back into, say, the host and place a breakpoint in the O call, just for fun. Scroll back up. Here's the O call. Put a breakpoint. So now the enclave will call back to the host,
Okay.
and we will hopefully see the breakpoint stop. And there it is. So the enclave has now called back into the host, and we can debug that too. So we'll release the debugger, and we can see here the output from the host that printed out the message that the enclave generated. Now you could say take this and we'll disconnect the debugger and stop QEMU. You can also go back into the run task list and build for TrustBox Edge if you wanted to. This will do the same thing as it did before, but it'll compile everything for the TrustBox, and you can take the enclave and the host, deploy them into your real device, and make sure that it works there too.
Yeah.
Just that easy.
Same code, everything works, even with the hardware and then your simulated device. Nice.
Yeah. And you could also take the same project and compile it against SGX. So it's the same APIs that you call.
Nice.
Okay.
Which is definitely great for a lot of the IoT solutions. We'll use different type of hardware devices. A lot of companies use mobile. They'll use Linux or Windows. So it's great that we have that option.
Yeah.
Edge and cloud too as well, right? Same code around SGX and cloud.
Right. If you were to compile the host and the enclave for SGX, and then you were to deploy that to an ACC VM, it will run there too.
So it runs on the cloud too.
It does. Okay, so let's now switch to the second part of the demo.
And then there was a question on, is it possible to debug on TrustBox?
Right. No, unless you have a hardware debugger, it's not possible to do that. Although you can ask Pamela to do that for you.
Yeah.
Okay. Yeah. Okay, so let's move on to the second part of the demo. And here we will be doing something similar to what we did before, but instead of deploying the standalone binaries to, say, the TrustBox, we can create an IoT Edge module and then deploy that at scale using Azure IoT Edge. So let's get started. In this instance, I'm not running remote. So this Visual Studio Code extension, this Visual Studio Code instance is running locally on Windows. And the reason why we can do this is because when we build our binaries, we're actually building inside Docker containers. So the fact that we're running on Windows doesn't matter. Of course, you could do the same thing if you wanted on Linux, and this even works on macOS. So let's have a look at the extension list, and we see that we have the same Microsoft Open Enclave extension installed here, which is the same one as we had with the Linux backend running on Windows. And we'll do new Open Enclave solution, same command. And the extension also prompts us for a location, so we'll say select folder, and we'll give a name, Edge 10. I created a bunch of edge ones, so make sure that it's far enough. And now the extension is asking us for an image repository. So where will the edge modules wind up? So let's open up Edge, and let's go to the Azure portal. And I have already created an Azure container registry here. So I'll just copy the URI for the container registry into that prompt. So here it is, OE channel 9 container registry. Click on this. And we will take the login server URI, copy this, and we'll put it here. So now when we compile the host on the Enclave and then they get put into an Azure IoT Edge module, that module will be pushed into this Azure container registry. And what we can do with that in turn is, if we go back to the Azure portal, I already have created an IoT Hub 2, and we can open that one up. And if we go into the list of IoT Edge devices, I have a question. No? Okay. I have a Scalise Greatboard device listed here, and it has been configured to be able to pull containers from that Azure IoT registry, Azure IoT container registry. So in that sense, we are able to push the module up to the Azure container registry, and via IoT Hub, the trust box will be able to pull, or a trust box, any trust box, will be able to pull that container and run it locally, including the Enclave in it. This should only take a moment longer. There he goes. Ah, perfect timing. Fantastic. Okay. Now, if you've ever used the Azure IoT Edge extension for Visual Studio Code, you might recognize the files here in the Explorer. So here's a deployment manifest template, and what this has in it is a list of modules to be deployed to any device that accepts this manifest. So here, for instance, is the settings for which which Azure IoT Edge agent version to use, which Azure IoT Edge Hub to use. We have here also the usual sample simulated temperature sensor, which also gets deployed to the device. And here's our own extra sauce, which is the module that we will build using the extension. It will also be pushed down to the device, and there's some glue that allows the container to talk to the ARM Trust Zone platform on Linux. So we've taken care of that for you. If we open up the modules folder, we see here that we have an EDL file again. It's the same one that we saw before. We have a host and an enclave. The enclave is the same code. But if we go into the main function here, main.c, in the host, we'll notice that there's a whole bunch of IoT Hub stuff. So what this is based on the samples for the Azure IoT Hub device C SDK. And it allows the host to communicate with IoT Hub and receive messages from it. So whenever an IoT Hub message is received in the host, it comes into this while loop that receives messages, and it takes the message, or any message, and it routes the message to the enclave. So that input string that we saw that the enclave takes and performs some signature on it, or could potentially perform some signatures on it, it is being called from the host to process IoT Hub messages. And those messages will in turn be the ones that are automatically generated by the simulated temperature sensor. So we'll be able to see this working.
Okay.
So let's go ahead and select down here the target device. So this is the TrustBox Edge we want to create containers for. So click on this, and we then do right-click on the deployment manifest template, and we will click on Build and Push IoT Edge Solution. So this will kick off an automated build. It'll do the same things as we've seen before, where it runs in CMake configuration step, and then it runs the build step. But all of this is taking place currently, or will eventually take place inside a Docker container.
Okay.
And then that gets packaged and sent off to the Azure IoT container, the Azure Container Registry. There's too many words. So once this is finished, actually we should see already the deployment manifest that was created especially for the TrustBox Edge. Now we won't wait for this to finish because it takes a little while, but we can right-click on this and say create deployment for single device.
Okay.
And here you'll see that the Scalise Greatboard device is the same one that I showed you before in the IoT hub. So I'm not going to click on this because I've done this already and I don't want to disrupt the current setup that I have, so I can show you
Makes
that it
sense.
works. But if you click on this, then the Azure IoT Edge agent, the hub, the simulated temperature sensor, and our custom module will be pushed down to any device that connects to this device in IoT hub. Oh, actually, the whole build just finished. And we can go back into the IoT hub and have a look at the Scalise Greatboard device ID. Click on this. And we'll notice that there are 4 modules that have already been deployed to it, and we see that they're all running. So this is the agent, the hub, the simulated temperature sensor, and the Edge module that contains a host and an enclave that I created before. And so what's really cool about this is that you can take an open enclave project that has the host, an enclave that was built using the same APIs that you can use for SGX.
Yep.
And it was all compiled into an ARM trust zone compatible enclave and then sent off to one device in this case, but it could be many. And you can run your confidential computing scenarios there just as easily as you could with a regular application.
What I love about this is the fact that if you're already working with the IoT Edge runtime and you've installed IoT Edge extension, it just fits in really nicely with the Open Enclave SDK, which is it's just nice. It's sometimes the extensions you have to install a lot of extensions to get something working, and it's great that you can just install the IoT Edge extension and Open Enclave and get working. Yeah.
We do have some dependencies. The extension will warn you and will tell you.
Okay,
to install
perfect.
other things. So
I spoke too soon.
No. Well, we do depend on the Azure IoT Edge extensions, for example. So when you install
That's true.
ours, it'll install the other.
Yeah, and then with if you just install the IoT Edge extension, you can actually install the full IoT Edge extensions that's created by Microsoft. So if you do Azure IoT Tools, you get IoT Hub, you get IoT Edge, the Workbench extension all in one in that extension pack.
Yeah, it's really interesting that you can have extensions that depend on each other, and then we install the top level one and it installs everything for you.
Yeah.
Okay, so that was it for the demo.
Great. Well, thank you so much for showing that demo. It was nice seeing what is the kind of the slight differences between Visual Studio and then Visual Studio Code, because we do have, different dev teams, preferred IDEs that folks like to work on. I'm going to bring Dave back on because he actually I'm going to go through the resource slide and then we'll showcase things working in his last demo. Okay, perfect. So if we show the resources slides, if you're interested in what you saw here, I thank Eustace, Dave, Herman for showcasing these technical demos and showing how to get started. And if you want to get started at home or at work, we actually have some great links for you to go ahead and do that. That would be... We're switching computers right now. That would actually, we have links to the Open Enclave itself, the SDKs, and we also provided a direct link for working with IoT solutions. So if you want to get more of the details, because if you go to the Open Enclave SDK, sometimes it's hard to navigate to actually getting the IoT details. So we provide that direct link. And then we also have our communities links too. So we have Microsoft IoT area and IoT tech communities. So that's where we're posting a lot of updates. We're posting a lot of new documentation there. People are asking questions. So Olivier, myself, and many of the Azure IoT engineers are there answering questions on tech community. So I'm just doing a plug there. So I will be adding these slides there as well. So if you head over there after the event, I will have those slides up. We also have IoT School, which if you're just getting started, maybe you want to get started with IoT Edge or working with IoT solutions and building IoT solutions, you can go to IoT School to get some more training. All right, I think we're going to since it was demo day, and sometimes demos don't always work the first time, we're bringing Dave back to showcase it working.
Okay, so all I've done is I've restarted the VM. And because of that, the IP address changed, and so I've just gone back in and rechanged the IP address in here. So you'll see it's now .164. You can see there's the old one. So that's the only change from before. Otherwise, it's exactly the same state as it was before. And so at this point, I'm going to hit F5. Okay. And so here, what you'll see it actually connecting to that IP address. This is the path where it works. You can see it's actually compiled both things. It's actually doing this by copying the sources over to the Linux machine, doing the compilation there. Okay, the compilation is done, and so since I hit F5, it's doing both the compilation and the running. And so at this point, it's actually starting up the application inside the Linux machine.
Okay.
And so you can see now it's broken at my first breakpoint. Down here, Visual Studio has this Linux console window here, and so as you see, it's actually mirroring the same output down here, so I can see before I start calling into the enclave, I've got this thing. Okay, if I then hit go, I've now inside. You can see now I'm inside the enclave. As Hernan said, when you're compiling in release mode, you can't do this, right?
Yeah.
Only when you're compiling in debug mode is the information available. Because what's happening is normal application like the debugger is peeking inside, right? Normally for a secure application, you can't do that, right?
Yeah.
It's only when you're in
Defeats the
debug
purpose.
mode. Okay. And so here, if I step over that, you can see there's the same printf happening here. And if I go again, here we are back, step down inside the O call, right? And so again, there. And so now if I look at the call stack here, you'll see that it's inside the O call, which is in turn inside the E call, which is in turn all the way back up inside my sample enclave call inside main, right? And I have full access to variables and so on at this point, okay? And so at this point, I can exit. It will exit cleanly. And last thing I will mention is up here the different configurations. This is where you choose debug or release. And you can see there's an SGX simulation debug. Now I'm showing you this demo on an SGX capable hardware, okay?
Yeah.
But do you have to have an SGX capable hardware to do this demo? No, you just have to choose SGX simulation to say I don't actually have real SGX hardware. But if I do have SGX hardware, I can debug that. Everything that I was doing this demo was actually using the SGX hardware, the chip inside this one here. My walkthrough was using Intel SGX. Hernan's was using ARM Trust Zone. The point is that we want the same SDK, the same code works with both. Okay, thanks.
Great. I love the fact that we can show the working demo.
Yeah.
And it was just restarting the
Just
VM.
starting the VM, yeah, I don't know.
Validation. Okay, well, thank you so much for joining for our deep dive into. We're
Grouping again.
we're coming close. Thank you for joining our deep dive where we discuss Open Enclave SDK. We gave a couple of technical demos. In the future, we're going to have a deep dive into plug and play and then DevOps for IoT Edge solutions. So I'm pretty excited for the upcoming ones. I want to do a special thank you to all of you. Thank you so
everyone.
much for joining, and
Thanks
thank you
for
for
joining
joining
us.
as well. So everyone have a great day. Bye.